Hi guys, welcome to this another video of this lecture series. So this is Dr. M.MOORTHI, working as assistant professor in the Department of Automobile Engineering, SNS College of Technology, Coimbatore. So this is the lecture series of the automotive engine and emission control, where in this lecture series we have discussed and discussing the topics of the importance of air fuel ratio, and then how the impact of air fuel ratio in emission and then engine performance. And then with in the last video we discussed about the impact of the air fuel ratio on carbon monoxide and then hydrocarbon. And then in this video we have discussed about the impact of air fuel ratio on emission like nitrogen oxide and then the particulate matters. So with that nitrogen oxide generally produced in the combustion chamber and then during combustion process because of the extreme generation of the temperature inside the combustion chamber. So while we are burning the fuel in the combustion chamber, so the air fuel ratio is the air fuel mixture is supplied into the combustion chamber, and you take a four-stroke engine. So we have intake stroke and then the suction stroke, and then next one is compression, then the expansion or power stroke, and then finally we have exhaust stroke. So during the power stroke or expansion stroke, so the air fuel mixture is burned, or the burning process will going to start, or the combustion process will going to initiate with the help of the spark plug in the spark ignition engine or SI engine or petroleum or gasoline engine. So with the combustion of fuel inside the combustion chamber, where the air fuel the air fuel mixture will going to burn because of the oxygen is present in the air. So this oxygen is capable to burn the fuel, is available inside the combustion chamber, and then it make the or it initiate the combustion process. So with the NOx emissions are formed at higher temperature when the nitrogen in the air react with the oxygen. As I said earlier, this NOx emission produced because of the extreme generation of temperature inside the combustion chamber. So this oxygen will react with the nitrogen, and it forms the NOx emission. When these reactions are more likely to occur in lean mixtures where the combustion temperature is higher. So in the lean mixture, there is a higher in with the air fuel ratio higher, that is the 14.7 is to 1, where the higher part of the air is available. The same time we have, when compared to air, we have lesser quantity of fuel is the present in the mixture. So with that higher quantity of air, it is more enough to supply the more enough oxygen to make the complete combustion process inside the combustion chamber, and then it leads to with that complete combustion, and then with increase the temperature of the chamber, so that it initiate or it's give the higher amount of the nitrogen oxide to the exhaust. So with the stoichiometric to lean mixture, the NOx emission typically increase as the mixture become linear because of the higher combustion temperature. With the rich mixture, the lower NOx emissions because the excess fuel tends to cool the combustion process and reducing the temperature and thus formation of NOx. And then particulate matter, with the particulate matter consists of tiny particles of soot formed from the incomplete combustion of fuel, particularly in rich mixture. As we discussed in the rich mixture, in the rich mixture air fuel ratio, there is a higher quantity of fuel is present in the mixture. It means when it gets the insufficient oxygen from the air fuel ratio, so that with the insufficient air it's applied in the combustion chamber, so that it is not enough to make completely burn the fuel, and then so that there is a part of that is the fuel is unburned, or it is emitted to the exhaust. So this rich mixture it tends to form the particulate matter in the higher range. And the rich mixture, the higher level of particulate matter are produced due to incomplete combustion and the formation of soot. And the next, with the lean mixture, generally lower particulate emission as more complete combustion process is taking place. As I said earlier, the rich mixture means we get the more quantity of fuel, and the lean mixture means we get more quantity of air. It's a vice versa. So rich fuel means there is a insufficient oxygen to complete to make the combustion process, means it form the unburned fuel at the, so this unburned fuel are the part of fuel, it is of as a particulate matters. And then with the lean mixture we get the more air compared to fuel, means this more air which supplies the more oxygen, so this oxygen is more than enough to burn the fuel completely, so that it liberate lesser particulate matter. And then next one is the optimizing air fuel ratio for emission control. So modern engine use various strategies to optimize the air fuel ratio and the emission. The first one is closed loop control system. So oxygen sensor in the exhaust monitor the air fuel ratio. As I said, so in this the air oxygen sensor is fixed in the combustion chamber, where when there is insufficient oxygen, means it articulate sense the requirement, and also it can supply this information to the ECU unit, and then it again it adjusts the air fuel ratio, and then it again it supplies the more quantity of air, so that it make the enough oxygen to make the complete combustion during the process. Or the another way we get the catalytic converter. So this is the device, it is attached to the exhaust manifold, so that this device reduces carbon monoxide, hydrocarbon and NOx emission by facilitating reactions that convert these pollutants into less harmful gases, as they work more efficiently at the stoichiometry air fuel ratio. Thank you.